Welcome. This video is a comprehensive list of the activity on the Sun over the last week. The X-ray flux is a good indicator of the level of solar activity on the Sun. The more M flares and X flares there are, then the more active the Sun has been. Also, coronal mass ejections are another important indicator. So let's take a look at some movies. We'll start at the surface of the Sun and then move outwards and upwards in temperature. So we're starting with the Sunspot movie from the Solar Dynamics HMI instrument, which has a characteristic temperature of about 5,000 degrees. What to look for here is large sunspots, emerging regions, decaying regions, and motions. Sunspots are areas of strong magnetic field, so the next obvious thing to look at is the magnetogram movie. Of course, that's the same temperature, but here you want to again look at the same regions, large regions, emerging regions, decaying regions, and motions of the sunspots and how they interact with one another. Around each sunspot region, there's usually an area called plage. These are bright areas which are emitting more radiation than the sunspots. To look at those, we use the 1700 angstrom continuum channel from the Solar Dynamics Observatory AIA instrument. You can see here the sunspots clearly, and the plage are the bright areas, but also the flares show up as little brightenings within those regions, so you can see where the flares are occurring with respect to those sunspots. So let's take a look at some movies of this. We'll start with the AIA instrument, helium-2 304. This is a transition region line with a temperature of about 50,000 degrees. We move up in temperature now to about 630,000 degrees Kelvin. That enables us to see the lower corona using the iron 9 171 angstrom channel from AIA. Here you can see magnetic loops, interconnections between regions, changes in those, and also the dynamics of the regions. Now again, we'll move higher. This is the iron 12 channel at 193 angstroms. This looks at the so-called quiet corona at a temperature of about 1.2 million degrees Kelvin. Here you can see what's called the magnetic carpet. This is low-level magnetic connections, and far from being quiet, they're changing all the time. You can also see coronal holes. These are the dark areas. Higher again in the corona, we look at the active corona using the iron 14 line at 111 angstroms. Here you see active regions, and on the limb you can often see dark areas, which are sometimes called tornadoes because they twist around. These are, again, prominences seen in absorption in this particular channel. Now we're going to look at the active regions themselves. These are the regions above the sunspots, and we're going to use the iron 16 line at 335 angstroms from the AIA instruments. The typical temperature here is about 2.5 million degrees Kelvin. So you'll see the active regions, and you'll see some of the flares as brightenings in those active regions. If we want to see flares, we have to look at really hot plasma, and to do that we're going to look at the iron 18 line at 94 angstroms, and that's got a typical temperature of 6.3 million degrees Kelvin. Here you'll see the active regions, but also you'll see the flares much more clearly as bright bursts in those regions. The hottest temperature that the AIA instrument can see is the iron 20 line at 131 angstroms. So this is really good at looking at flares because the temperature maximum of that particular line is about 10 million degrees Kelvin. Next, we'll take a look at the Soho-Lasco C2 instruments data. That is the high resolution images of the inner corona. It's done in visible light, so this is light scattering off the material as it moves away from the sun, and of course it shows coronal mass ejections very clearly, which is what we're really after here. Lastly, we'll take a look at the data from the Soho-Lasco C3 instrument. This is the large field of view, but it's at lower resolution. You can see again the CME moving out. We can get some idea of what's about to come onto the solar disk using a couple of tools that we don't normally use. First of all, we can use the EUVI instrument on stereo. Stereo is a couple of days behind the Earth, so we can see 2 days behind the limb. The other tool is helioseismology, which uses the vibrational states of the sun and can actually image the far side of the sun. And dark areas on these plots show conglomerations of magnetic field, which are probably strong active regions.